Okay, hey guys, so today we're going to go ahead and go over day 4 notes, oxidation-reduction reactions, or you can call them redox reactions. Okay, so reaction types are put into 3 different categories. All of the reaction types we've discussed can be placed into one of 3 categories. So the first one is your acid and base or neutralization. We also have precipitate reactions, and we also have oxidation-reduction reactions, or redox. So in this unit, we're actually only going to be going over precipitate and redox reactions, okay? So today, again, we're going to go over redox reactions, okay? So redox reactions consist of synthesis, decomposition, and single replacement reactions, okay, which we'll go over into more detail tomorrow. So in redox reactions, the oxidation number for an element changes in a chemical reaction. So oxidation numbers, what those are, is a number assigned to an element based on the distribution of electrons. The same element can have very different properties in different oxidation states. Okay, so if you guys remember, a long time ago, we've talked about oxidation numbers before. Okay, and when you look at your periodic table, we wrote down our oxidation numbers. So oxidation numbers are also the charges of our atoms and ions, okay? So anything in group 1 is going to be +1, group 2, +2, 3, positive or -4, -3, -2, -1, and 0. Okay, so again, oxidation numbers are the same as charges. Okay, so there are going to be rules for assigning oxidation numbers. So rule number 1. Okay, the oxidation number for any uncombined element is going to be 0. So when it says uncombined, that means it's all by itself. It's not attached to any other element. So in this case, we have sodium. So sodium is all by itself, so its oxidation number is going to be 0. Okay, you have another example, O2. So again, because oxygen is all by itself, it's not connected to any other element, it's also going to have a charge of 0. Okay, so again, anything by itself is going to have a charge or oxidation number of 0. Okay, rule number 2, the oxidation number of an ion is going to equal the charge of the ion. So in this case, we have chlorine with a -1 charge, so its oxidation number is going to be -1. Okay, so rule number 3, the oxidation number of elements and compounds typically, but not always, follow a trend on the periodic table. So again, whatever your group number is, that's going to be your charges. Okay, again, we wrote those oxidation numbers on our periodic table, right? So anything in group 1 is going to be a +1, group 2, -2. If you're in group 6A, then it's going to be -2. Okay, so those are just a few examples. So if we take a look at the examples we have in our notes, okay, so if we take a look at the compound lithium fluoride, okay, what is our charge for lithium? Well, all we have to do is take a look at our periodic table. So lithium is in group 1 right here, so its charge is going to be a +1. Okay, now how about the calcium in calcium carbonate? Well, calcium is in group 2, so it's going to have a +2 charge. Okay, how about the fluorine in hydrogen fluoride? Well, fluorine on our periodic table is right here in group 17 or 7A, so its oxidation number is going to be -1. Okay, and then lastly, the hydrogen in H2O. Well, hydrogen is also in group 1, so it's going to have a positive 1 charge. Okay, so basically if you have a compound, you can always look at your periodic table, or you can use your crisscross method to find your charges, okay, which you'll later see in our examples, our practice problems. Okay, so moving on to the last rule, rule number 4. The sum of our oxidation numbers of all the atoms in a neutral compound is 0. So when it says neutral compound, if you just take a look at these examples right here, LiF, well, there's no charge, so that's going to be a neutral compound. Calcium carbonate, no charge, so this is also neutral. But if you take a look at our last one, this compound, this polyatomic, has a charge. Okay, so it has a -2 charge. Okay, so again, this is going to be an ion, while these two, because there is no charge, these are neutral compounds. Because they're neutral, their total charges have to equal 0. So let's go ahead and take a look at lithium fluoride. So lithium, according to our periodic table, okay, lithium is right here in group 1, so it has a positive 1 charge. Okay, and then fluorine, if we take a look at our periodic table, remember fluorine has a -1 charge. So if we combine +1 and -1, well, our total charge is 0. Okay, we have to have a neutral compound in the end. Okay, calcium carbonate. Well, calcium on our periodic table, let's look for calcium. Calcium is right here, so it's a +2 charge. Okay, so let's take a look at carbon. Carbon can be either positive or negative. So let's skip carbon for now, since we're not really sure which one to use. Okay, now let's take a look at oxygen. Oxygen, it tells us it's a -2 charge, but we have 3 oxygens. So -2 times 3 is -6. So if oxygen is -6 and calcium is +2, well, what does carbon have to be to equal 0? Okay, carbon has to be a +4 so that our end result, or our total oxidation number, equals 0. Okay, so looking at our polyatomic ion, polyatomics are going to be the exception. Okay, we're going to have to start with oxygen first, because we know oxygen is a -2 and we have 4 of them, so that total charge is -8. So if oxygen is -8, then what must sulfur be to equal -2, right? So sulfur actually has to be a +6 in order for our total to equal -2. Okay, so these are really important, and you must know these if you have any intention of figuring out what type of redox reaction you have. Okay, so please, please, please be familiar with these rules. Remember, rule 1 is that if it's all by itself, it's going to be a 0 charge. It's going to be a neutral element. Okay, if you have an ion, or if your element has a charge, then it's going to be that number. Okay, so if it's a -1 charge, then your oxidation number is also -1. Okay, if you have a compound, if you have any compounds, then just refer to your periodic table to find out what your charges are. Or again, you can always use your crisscross method if you're comfortable with that. Okay, so let's go ahead and take a look at some vocabulary terms that you guys are going to have to be familiar with. You guys have to memorize these. Okay, so oxidation, let me just make this smaller for now because we don't need it. Okay, so oxidation. Oxidation is a reaction in which there is a loss of electrons. Okay, so if we're taking a look at our example here, we're taking a look at sodium. Okay, sodium, remember, if it's by itself, it's going to have a zero charge. It's going to have a neutral charge. Okay, but when we take a look at our product, it lost an electron. Okay, so it went from sodium to sodium plus an electron. So that means we've lost an electron in our sodium atom, resulting in a +1 charge. So because you have a +1 charge now, you went from a 0 charge, you went from a neutral charge to a +1 charge. That means you've become more positive. You have lost an electron. Okay, so there's again two different ways that you can tell if you have an oxidation or a reduction, and that's by looking at where is your electron. So in this case, our electron is in our product side, so I've lost an electron. Or if you're not given that electron, you can always just look at your oxidation numbers. You went from a 0 to a +1. Okay, you've lost an electron. Okay, you also have reduction. So reduction in a reaction is where you gain electrons. So if we take a look at our example, okay, without looking at our oxidation numbers, you have chlorine plus 2 electrons. So again, you're adding electrons to your equation. That tells you you have gained electrons. It's a reduction reaction. Okay, or again, if you weren't provided with an electron, take a look at your oxidation numbers. Okay, chlorine all by itself with no charge, you have a neutral atom, so it's going to be 0. But if you take a look at your products, you have a -1 charge. Chlorine became a -1 ion. So you went from 0 to -1, you have gained an electron. You're becoming more negative. Okay, so because you have to memorize oxidation versus reduction, these are two different ways you can memorize it. So Leo the lion says grr. So Leo stands for losing of electrons is oxidation, and gaining of electrons is reduction. Okay, so that's Leo the lion says grr. Or you can use oil rig. Oxidation is loss and reduction is gain. We're mainly going to use this one. I think it's easier to remember, oil rig versus Leo the lion says grr. It's also shorter. Okay, oxidation is loss, reduction is gain. Okay, so since oxidation is the loss of electrons and reduction is the gain of electrons, they must occur simultaneously. Okay, any chemical process in which electrons undergo changes in oxidation number is a oxidation-reduction reaction, or redox reaction for short. Okay, so you will always have one and the other. Okay, in any equation, you are going to have an element that's undergoing oxidation, and you're going to have another element that's undergoing reduction. Okay, so you will have both in a reaction. So let's go ahead and take a look at our examples. So example number 1, we have iron plus oxygen yields iron oxide. Okay, so remember, let's take a look at what our charges are first. So iron, it's by itself, so it's going to have a charge of 0. It's neutral. Okay, oxygen, again, it's by itself, so it's a neutral atom. It's going to have a 0 charge. But here we have a compound. So remember, you can either look at your periodic table or you can use the crisscross method. I prefer to use the crisscross method. So remember that our subscripts can crisscross, and they're going to become the charges of our compound or our element. So that 2 is now going to become the charge for oxygen, and this 3 is going to become the charge for iron. Okay, so how do you know which one is positive, which one is negative? Our first element is always positive. our second element is always negative. Okay, so iron is going to have a charge of +3, oxygen is going to have a charge of -2. Okay, so when we fill out our table, we have iron and we have oxygen. Okay, the oxidation number on the reactant side for iron is 0, and oxygen is also 0. On our product side, iron is a +3, and oxygen is a -2. So our next column, did we lose an electron or did we gain an electron? So if we're going from 0 to +3, I'm becoming more positive. So if I'm becoming more positive, I have lost an electron, and I've lost 3 electrons. Okay, oxygen, I went from 0 to -2. I'm becoming more negative. So I have gained 2 electrons. Okay, now remember oil rig. So oxidation is loss of electrons. Reduction is gain. So if I've lost an electron, then that means my element has been oxidized. And if I've gained an electron, that means I have reduced my element. Okay? All right. So let's go ahead and take a look at our second example. Okay, so our second example, we have magnesium plus hydrochloric acid yields magnesium chloride plus hydrogen. Okay, so magnesium is all by itself, so it's going to have a neutral charge. It's 0. Okay, our next elements, they're compounds. So remember, you can either look at your periodic table. So hydrogen is a +1 charge, and then chlorine is a -1 charge. But remember, I told you guys about the crisscross method. You have an invisible one here and an invisible one right there. Okay, so if you uncrisscross them, well, you have a +1 and a -1. Okay, so let's take a look at our next compound. Okay, so we have magnesium and chlorine. So if you're using your periodic table to find out what your charges are, magnesium is in group 2. So it's going to have a +2 charge. Okay, and then chlorine has a -1 charge because it's in group 7A. Okay, so again, if you want to use the crisscross method, it's still the same thing. Magnesium is a +2, chlorine is a -1. So you can use either method. Okay, so again, hydrogen is by itself, so hydrogen is going to have a neutral charge. All right, so our elements, we have magnesium, we have hydrogen, and we have chlorine. Okay, magnesium was a 0 on our reactant side, hydrogen was a +1, and then chlorine was a -1. On our product side, magnesium was a +2, chlorine is a -1, and then sorry, that's not chlorine, this is chlorine. Hydrogen was a 0. Okay, so did we lose or gain? We went from 0 to +2. We became more positive, so we lost 2 electrons. Okay, hydrogen went from a +1 to a 0. We're becoming more negative, so we have gained 1 electron. And then lastly, we went from -1 to -1. We did neither. We didn't gain, nor did we lose. Okay, so remember oil rig, oxidation is loss, reduction is gain. So if I've lost electrons, then that means I have oxidized my element. Oops. Oxidized. Okay, and then if I've gained, that means I have reduced my element. And then again, neither is going to stay neither. It was neither reduced or oxidized. Okay, so at this time, I want you to go ahead and try number 3 on your own. So go ahead and pause the video and then try to work it out on your own. And then when you're ready, just push play so that way you can check your answers against mine. Okay, so we have iron oxide plus aluminum yields iron plus aluminum oxide. Okay, so again, we have a compound. So I like using the crisscross method, so that means iron has a positive 3 charge and oxygen is going to have a negative 2 charge. Aluminum is all by itself, so it's going to be a neutral atom. Iron is by itself, so that too is going to be neutral. Okay, and then we have aluminum 2, oxygen 3. So aluminum is going to have a positive 3 charge, and oxygen is going to have a negative 2 charge. Okay, so let's fill out our table. We have iron, oxygen, and aluminum. Iron was a positive 3, oxygen was a negative 2, and aluminum was a 0. Okay, now on our product side, iron is 0 because it's by itself. Oxygen is a negative 2 charge, and aluminum is a positive 3. Okay, so did it lose or gain? Well, we went from positive 3 to 0. We're becoming more negative. So we have gained 3 electrons. Okay, oxygen stayed negative 2 to negative 2, so it's going to be neither lose or gain. Okay, and we can already go ahead and fill this one out for oxidized or reduced because you know it can't be either one. And then we went from 0 to positive 3. We're becoming more positive, so we've lost some electrons. Okay, so remember oil rig? Okay, reduction is, oxidation is lost, so the lose 3 is going to be the one that's been oxidized. And then the gain 3, reduction is gained, so reduced. Okay, so hopefully this made any sense. If you have any questions, please ask.